Hello, my name is Ashley Bantock and I'm a Cisco instructor here at Global Knowledge, and I'm just going to take you through a quick simulation on how VTP works and the basics. So let's look at VTP as our protocol. There are three modes in VTP. There is server, there is also client, and there is transparent. Now in our topology, I'm going to have our server switch and I'm going to have two client switches for now, client 1 and client 2. Now in this topology, in VTP, everything is governed by the revision number, and this is a new topology, so currently all of our devices are on revision 0. So we're all on revision 0. However, I'm going to jump onto my server switch, and my server switch I can add VLANs. The client switch I cannot add VLANs. That's one of the major differences. And what I'm going to do is I'm going to add VLAN 1 to our server switch. And as soon as I do that, as soon as I add VLAN 1, that now takes out the revision number and increments it to 1. That now sends an update from our server switch all the way to client switch 1. Client switch 1 then looks at that update and he sees, your revision number's higher than me, it's revision 1, and he takes on whatever was in that update and the fact that he needs to take on the VLAN database update, so he now adds VLAN 1. That update of course continues on its journey down to client switch 2, and client switch 2 also does exactly the same. He now has revision 1 and he now has VLAN 1 added to that particular switch. I'm now going to add VLAN 2 to our server switch, and again that sends an update straight out to client 1 and to client 2, and because it's now an update going out, they then check the latest revision number, which has now changed. The revision number has now become revision 2, and so on all the other switches we also increment our revision. So here it becomes revision 2 and here it becomes revision 2, and now we can write in the VLAN that's been added. So VLAN 2 has now been added. Everything works based upon that key revision number. Highest is best. Now a client can update a server, so the revision number rules. It doesn't matter what mode you're in. Now with transparent, you're also always set to revision 0. It never ever increments. In fact, if I put a transparent switch in this topology, it never goes higher than revision 0. It stays there, and any VLAN you create on that transparent switch, it stays. It doesn't send out any updates. It's like placing a bubble around that switch. But let's take a different scenario, typical scenario with VTP. Now with VTP, on Friday afternoon, for example, someone turns around to you and they say, we've got 100 new users starting on Monday morning. The trouble is, you haven't got any spare switches that are new just to put in this topology. You only have this one switch that has come from your testing lab. And in your testing lab, it's been running some different VLANs. It's been running VLANs 6, 7 and 8. It's currently configured as a client switch, so let's make this client 3. And its revision number is currently set at 200. Now we look at the switch and we say, oh, okay, let's clear out the config. So we erase the startup config on our particular switch, and then we add this switch into our topology. And disaster strikes. All of a sudden, any client on our network, and we'll look at this client down here, he is in VLAN 2. The trouble is, our switch has now received a VTP update from client 3, and the revision number is set to 200. So what our switch has now done is gone, oh, revision number 200. I'll update a revision number, and you're running VLAN 6, 7, and 8. Okay, I'll overwrite my VLAN database. So he completely overwrites it, and then he writes in the new VLANs of 6, 7, and 8. The same happens on our other switches, revision 200, and he adds in the new VLANs, 6, 7, and 8, and the same also now happens on our server switch. He now moves up to revision 200, and he has VLAN 6, 7, and 8. So even though it's a server, a client switch, this client switch down here, can still update that server. But here lies the problem. We've got this packet that's being delivered from our client. It's hitting client switch 2. And that client switch is going, oh, VLAN 2. He then looks in his VLAN database and goes, oh, there is no VLAN 2. And he bins that packet. He places it in the rubbish bin. That packet has his life terminated at that switch. It doesn't maneuver around the topology. All of a sudden, you have isolated anyone that was originally in VLAN 2, VLAN 1 on that switch, because they do not exist in the VLAN database. And that is a very big problem with VTP. Now, to stop that from happening, you can put all of your devices into what we call a VTP domain. So we can create a domain, let's say the Cisco domain. But the best protection is to add a password to that particular domain, just in case anyone decides to bring in their own switch and plug it into the network, because they can create a denial of service attack. Now, if it is one of your switches and you do want to add it into the network, well, now, instead of doing an erase config, you need to check where the VLAN information is stored. And in fact, the VLAN information is stored in a file called vlan.dat. That is stored inside the flash memory. So, there are two main ways of adding a switch to the topology. You could take this switch and put this particular port or this particular switch into VTP transparent mode first. By doing that, it now puts the revision number on this particular switch all the way back down to 0. And what will then happen is you add him to the network, so you join him up to the network, you connect him, and he should then learn from the network when you move him back to VTP client or server. So he learns from the network. He doesn't tell the network what the VLAN.dat is. That's a very safe way of adding a switch. Optionally, you can delete the VLAN.dat. So command is delete VLAN.dat. But you have to make sure you reload that switch first to get rid of that file, and then you can start again. And of course, if you have any passwords configured, you need to make sure your device has got those configured also. So be very, very careful with VTP. Now we do now advise, in fact, that you turn VTP off. And to actually turn VTP off in a network, we now advise that you do put all of your devices into transparent mode and that you go round to each of your switches individually, adding VLANs. That seems to be the safest way with VTP these days. So with VTP we had 3 modes: server, client, transparent within VTP itself. The server can add, change and delete VLANs. The client can't do any of that, so he can't add or change any VLANs. And transparent, well, if you took a switch, it's like placing a bubble around that particular switch, and he always stays at revision 0. He never ever sends or synchronizes any VTP updates out on the network. Other features that are included in VTP include things like VTP pruning, where it will prune links where it feels a switch hasn't got that particular VLAN. Something that we also advise turning off now, and just using the VLAN or allowed command on your trunk ports. Other things to configure, well, VTP domain names, and of course the VTP password, just to protect your network. Now I'd like to thank you for your time listening to this short presentation on VTP.